Okay, in this video we are going to walk through some mini examples on solving quadratics using different methods. So this first method, we are going to solve the quadratic, which means we're going to get all the way down to what x equals, but we're going to do it by factoring. Now, there's a few things that you need to remember about factoring. Okay, so first and foremost, if your a is greater than 1, then it's recommended to use what's called the AC method. Now, to this end, I like to use a shortcut idea, which is called bottoms up. And so in this case, that is what I'm going to show you. I'm going to go ahead and show you the bottoms up method. The reason for that is because my a term is greater than 1. Now, the second thing that you need to make sure is you need to make sure that you always start from standard form. So as a reminder, standard form is ax squared plus bx plus c equals 0. Now in this case, I'm not set equal to 0, I'm set equal to 2. So the first thing I need to do is I need to rewrite my problem so that it says 6x squared minus x minus 2 equals 0. Now I need to work through what this bottoms up method is. So this bottoms up or AC method says the first thing you need to do is you need to take a times c and find out what that equals. So in this case, I'm going to have 6 times a negative 2, which gives me a negative 12 as a result. Now the second thing that you have to do is you have to find the factors of AC that add or subtract to the B term. So what that means is that I need to find my factors of 12. So I'm going to go ahead and just list all my factors. So I have 1 and 12, I have 2 and 6, I have 3 and 4. Now my B term, if I look at my standard form, is this middle term here. It's the x value, negative 1. So I need factors, my factors here, that when added together give me negative 1. Now, I could go through, well, I can have a negative 1 or positive 12 or a negative 12, positive 1. However, there's a trick that we can use. So we have a sign trick. And the sign trick says, when you look at this last term here, this tells you which sign combinations to choose from. So what that means is that I have sign combinations that say positive times positive equals positive, negative times negative equals positive, or positive times negative equals negative. So this back term tells me which one of these combinations I have to use. So I'm multiplying to a negative, which tells me the only combination I have is my last one. And that's the combination I have to use. Now, the other cool piece is that we have this middle sign. So in some cases, this middle sign will tell you which option to choose. But if we use this negative 1, then my middle sign has a different meaning. And my middle sign here is going to tell me that your bigger factor must be negative. So because of that, I know when I am looking at all of my factors that my tiny factors over on this left-hand side are positive and my right-hand side, or the bigger factors, are negative. Now I need to know which combination of those terms when combined is going to give me a -1. So if you look, the only one that's going to work is this last one, where I have +3 minus 4. Okay? So I have found my factors. After finding the factors, the third thing you're going to do is you need to set up your factors. Now we are going to use a form that's going to look a little bit bizarre, but it works really, really well. So essentially what we're going to do is we are going to set it up so that we have x plus or minus your factor value or number divided by the a term. And you are going to set that up for each factor. So we have +3 and -4. So this says we're going to set this up where we have x plus 3 over, and if you remember from the beginning, our a term was 6. And then we're going to have x minus 4 over 6. The next thing we have to do is we have to reduce the fractions. So in this case, my factors are going to become x plus, and I have 3 over 6, which is going to reduce down to 1 over 2. And then on the other side, I have x minus, and here I have 4 over 6. I can take a 2 out of both, leaves me with 2 over 3. The last thing I have to do is called bottoms up. So bottoms up essentially says anything that you have left in the bottom is going to shoot up and become the coefficient to your variable. Again, do it again. Anything that you have left in the bottom is going to shoot up and become your coefficient to that variable. So in this case, we end up with 2x plus 1 times 3x minus 2. Now, we can double check this by foiling it back together. Okay? So if we were just factoring, we'd be done. But in this case, we're solving. So we need to set this equal to 0, which means the very last step we have is we have to solve each factor for the variable. So what that means is I have 2x plus 1 equals 0, and I have 3x minus 2 equals 0. On this first side, I'm going to subtract 1 and divide by 2. So x is going to equal -1/2. And on this next other side, I'm going to add 2 divided by 3. So x equals 2/3. And in this case, this was what we were looking for. So there is an example of solving a quadratic by factoring. Alright, let's look at another quadratic, and let's look here again at a different method. So here we want to solve by the square root method. Now, the reason we can use the square root method is because if you notice on the left hand side, all I have is a binomial squared, and on the right hand side I only have constants. Because that occurs, we can use the square root method. So the square root method says the first thing you need to do is you need to take the square root of both sides. So we're going to take the square root of both sides. What means for my binomial is the square root goes away and leaves me with x minus 7. And then on the other side, we need to remember that taking the square root says we have plus and minus, and this becomes the square root of 12. Now the next thing that you're going to want to do is you are going to want to reduce the radical. So I have the square root, so I've got plus or minus the square root of 12. So I'm going to reduce my radical down. 12 can break down into 3 times 4, and I know 4 can break down into 2 and 2. There's my identical group of 2, so I'm going to pull that out. So this means I'm going to pull out the 2, and I've got a 3 left over. So my plus or minus square root of 12 is going to become plus or minus 2. Let me rewrite that here. Plus or minus 2 square roots of 3. So I can rewrite my little equation that I have x minus 7 is equal to plus or minus 2 square roots of 3. Now the last thing that you need to do is you need to isolate the variable. So that means I need to take this 7, move it to the other side. So x is equal to 7 plus or minus 2 square roots of 3. Now for some, if you leave it like this, that's perfectly fine. However, in some instances, we want them to be separated out. So the other way that you can write it is that you have 7 plus 2 square roots of 3, comma, 7 minus 2 square roots of 3. And what that does is that definitely signifies that you have 2 answers, which should make sense considering the fact that you are working with a quadratic formula. Alright, now let's look at a fun one, completing the square. So to complete the square, we've got a few things that we have to remember. First, the x squared term must have a equaling 1. So if that does not occur, then the first thing you must do is divide it out and make that happen. In this case here, I have my square term and it's got a 2, so I have to divide everything by 2 in order to make this a 1. So in this case, I'm going to have my 2w squared minus 4w equals 8. I have to divide everything by 2, so this is going to reduce to become w squared minus a 2w is equal to 4. Now the second thing that you have to do is you need to make sure that all variables are on one side of the equals and all constants are on the other. Meaning we are separating out your variables from your constants. And if we look at our equation, we've got that. Okay? So since our equation is exactly the way we want it, this is where we go ahead and start completing the step. So the first thing that I like to do is I like to rewrite my equation and put the spaces in it. So I'm going to have w squared minus a 2w, I need a space because I got to add something to it, is equal to 4, and again I'm going to put my space. So with that, what I have to do is, in order to figure out what goes in these blanks, I have to do the complete the square step. So the complete the square step says that we are going to take b divided by 2 and then we're going to square it. So when I do the complete the square step, I like to do these next 4 parts every single time because I basically do everything I need to do at once. So I have to do b divided by 2. Make sure you bring the sign with it. My b term is negative 2. So this is negative 2 divided by 2 and square it. Now don't skip ahead. I need to reduce that fraction. Negative 2 over 2 is going to give me a negative 1 and square it. When I square the negative 1, I get 1. Now, why did I painstakingly do all of those steps together? Well, the reason for it is simple. This last term right here is what gets added to this spot and to this spot. So that's the first part. Okay. So I very easily can rewrite my equation to say that I have w squared minus a 2w plus 1 is equal to 4 plus 1. Now, completing the square says that what we were doing is turning this part into a perfect square. And in this case, 5 plus 1, or 4 plus 1 is 5. I know my variable is a w. Now, this is why you do the other piece. And it's because the number that is right in here, sign and all, is what makes up the value that goes in that parentheses there. In other words, this becomes minus 1. And the last thing we know is that this has to be squared. So this sets up your completing the square. So here, I now have to take the square root of both sides. So this becomes w minus 1 equals plus or minus the square root of 5. So w is equal to 1 plus or minus the square root of 5. And there you have it. That is everything you need to know to complete the square. Alright, our all-time favorite here is solved by the quadratic formula. So what you need to remember is the quadratic formula says negative b plus or minus the square root of b squared minus 4ac, and the whole thing is over 2a. So what you have to do is you have to make sure that you are in standard form. And then the second thing you need to do is you have to plug in A, B, and C. And then the last thing is you are going to simplify. Now the reason why those are our steps is because our formula is technically x equals. So we have already solved, we just have to plug and chug. In our problem here, we have that A is equal to 1, B is equal to negative 4, and C is equal to 13. Now the other thing that we have is we plug those values in. So here we've got x is equal to negative of the negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 13 all over 2 times 1. Now we need to simplify each part. So in this case, negative and negative is positive. 4 plus or minus the square root. So 4 squared is 16. I have minus positive positive, so this is negative. And I have 4 times 13, which is going to be my 52. So this is minus 52, and the whole thing is over 2. In this case, what you need to do is we need to take this values in here, and we want to simplify. So here I have 16 minus 52, which is going to give you a negative 36. So my problem here becomes 4 plus or minus the square root of negative 36 all over 2. Now, when we look at this, notice we have a negative under the radical. So we got to take this negative and pull it out. This is now imaginary. And the square root of 36 is 6. So again, this simplifies down to being 4 plus or minus 6i, and the whole thing is over 2. The last thing we need to do is divide by that 2. So here we've got 4 over 2, which is going to reduce down to 2, plus or minus 6 over 2 becomes a 3, and we have the I. Now here again, because this is imaginary, I cannot combine it at all. So we have x is equal to 2 plus or minus 3i. Now the other way that you can see it is to separate it. So x equals 2 plus the 3i, and x equals 2 minus the 3i. So those are 4 different methods of being able to solve quadratic equations and get them down as far as they can go. So if you have any questions, please let me know. If you feel like you need extra examples, let me know that too. Otherwise, I hope you enjoyed, and I will see you next time.